Hello friends, welcome to the Tech Granth. Today we'll talk about another low level design, and this is the low level design of parking lot. So we'll go through the requirement, and after that I'll just show you a high level diagram of the parking lot, and then we'll move into the code. So the requirement here for our parking lot is that it should be a multi-level parking lot. So there will be multiple floors where user can go and park their car. Then multiple categories of parking space. What multiple categories means is that it should allow multiple kind of vehicle. So your parking lot should have space to park a normal car like a hatchback or a sedan or an SUV. It should have space to park a two-wheeler motorbike. It should have a separate space to park bigger vehicle like a bus or a truck, and so on. Maybe a special place or a special slot for parking vehicles for a special person, like if someone is pregnant, so for pregnant women or for handicap there should be a different parking space. And also there should be a different parking space if you are allowing to park a electric vehicle, so that you can give a slot so that they can charge their vehicle. So that way there should be multiple category of parking space. Next thing is that there should be multiple entry and multiple exit. So this will allow a condition where concurrency can happen. There can be a race condition for a slot. So we will handle this. In our code will not handle this, but I'll show you how there will be a very small change which will allow you to handle this. Next is that it should not allow more vehicles than allocated for each of the category. But your code should be such that if suppose tomorrow if you want a smaller vehicle to be parked in a larger space, so that should be allowed. It will just be that the charge will be as per the bigger space, but for now it's okay if you don't allow them to park a smaller vehicle into a bigger parking space. And charge should be hourly basis. This should be configurable, and you should display the number of vehicle for each parking space and how many spaces are empty, how many are occupied. All those detail can be notified at the entry gate. So these are our basic requirement. Let's see the high level diagram. So when user comes, user will go to the counter, which will be at the entry gate for collecting the ticket. So how the ticket collection will happen? There will be a guy who will be sitting at the counter who will help the user to get the ticket. So the guy will enter the user vehicle number. It will capture the vehicle number. It will capture the category, and then it will check whether the it will check with space allocation service. Basically the UI will make a call to the space allocation service to see what are the vacant space for this category of vehicle. If there is no space, then from here itself the guy should return saying that the parking lot is full for that particular guy. And once the space is allocated, then for that particular allocation we should basically create a ticket. Now this service will also have a component which will be this service will run for those guys who are at the exit gate also. So at the exit gate what will happen, the user will give the ticket. So in the ticket there will be a ticket number, the entry time, and that should be basically entered by the guy at the exit gate. And the API will make a call to the payment service, and payment service will calculate the charge and it will basically go ahead with the payment. Now the payment can happen using a payment gateway, or the guy at the exit gate can collect cash on behalf of the user. So those are the thing. In this particular low level diagram, we will talk about the classes and the component that we'll use as part of the ticket counter service and space allocation service. We'll not deal with the payment service. We'll do the charge calculation, but will not interact with the payment gateway and make the actual call there. So let's jump into the code. But before jumping into the code, let us see one more thing. What are the basic classes that we are going to create as part of this parking lot? So from here we see that we should have multi-level parking lot. So there should be a class for the parking lot itself. Then we should have a class for the floors. So basically there will be multiple floors of parking, and parking lot will have this class. So this class should be parking floor should be composed as part of the parking lot, and each floor will have some lots. So this lot will be nothing but the actual parking space. So this lot should be composed as part of the parking floor. So keeping all these things in mind, let us walk through the code for the parking lot. Okay, so this is the base class that we will start with. So we'll have a parking lot class. It will have a name, which will be the name of the parking lot. It will have an address. So address will have nothing but things like the street, block, city, country, all those things to give the address of the parking lot. Then, like I told, there should be a composition here. So parking lot will contain a list of floors. So this will tell us how many floors are present in the parking lot. Now next we'll go to the parking floor. So in parking floor, we'll have the name of each floor, like floor 1, floor 2, or we can name the floor with some alphabet like A, B, C, or some naming convention that you can follow. Next, in the parking floor, we will have a map which will contain a type of the parking, and it will be a complex map. So it will be a map of map. So this will contain each of the slots. So this map will be the name of the parking slot, and the parking slot object itself. So what parking slot will contain? We'll go into parking slot, but before going into parking slot, let's look into the parking slot type. So what is a parking slot type? So parking slot type will be an enum, and this parking slot type will be defined for our own vehicle type. So what kind of vehicle can be parked, or what all kind of slots that we are giving to a user. So our parking slots type are of two-wheeler, compact, medium and large. These are the four categories that we are giving now. In future, if we want to extend, we can extend this enum. Now in this enum itself, I have created an abstract method which is for calculating the price. Now this price can be basically configured if you are using a Spring Boot application. So this can be externalized. You can put it in some external configuration and ingest it using spell. So spell is nothing but Spring Evaluator, and it can be ingested at runtime. And all these, rather than hard coding, we can externalize this as a configuration. So we'll have a parking slot type here, and the once we have the parking slot, so on the parking floor we have map of parking slot type. So for each parking slot type we have another map. So what it means is that for two-wheeler I have a set of slots. So for two-wheeler I will have multiple parking slots that is available to me. So I will have, we suppose you go to first floor. So in first floor you have 10 parking slot which will be there for two-wheeler. So what this map will contain is that for two-wheeler there will be a map which will contain multiple slots with the name of the slot and a parking slot object. So let's go into parking slot object, and then I will come back and I will explain about this particular map. So parking slot object is the actual parking slot where the vehicle will be parked, and that slot will have a name. It will have a boolean variable which will tell us that whether that slot is available or not. By default it will be true, saying that all the slots are available. As and when the slots is occupied, this variable will be changed to false. Then the parking slot will also contain a vehicle object. So this vehicle object will be the vehicle that is going to be parked as part of that particular slot. So it will contain the vehicle number, and it will contain a vehicle category. So similar to the parking slot category, there will be a vehicle category which will be two-wheeler, hatchback, sedan, SUV or bus. So hatchback, sedan, SUV, these can be mapped to either a compact or a medium vehicle, and bus can be mapped to a large slot type. We'll go into all these in detail later down the video. So parking slot, it has a vehicle, it has is available, it has name, and also it has a parking slot type. So basically it will tell that which vehicle is parked in which slot. Why this has been extended, or why this slot type has also been introduced here, is because in future if we want to allow a smaller vehicle to be parked in a larger spot, or like that kind of situation, or maybe A smaller vehicle can be parked in a slot which is empty for electric vehicle if the number of electric vehicles stored are very less, that kind of scenario. So that can be helpful here, because charging will always happen based on the parking slot type. It will not happen based on the vehicle type. So that is what we have done here. So if the parking slot is clear, now this particular map will be little more clearer. So what this map will store is that for each parking slot type, it will have a list, it will have a map which will contain the parking slot name and a slot. So suppose we have a two-wheeler parking. So what it will store is, for two-wheeler, if I have 10 slots, so it will give the slot number. So it will be like, suppose it's on first floor, so it can be F1 and the slot number, F2 and the slot number, F3 and the slot number, something like that can be entered here. So parking floor will have multiple parking slot. And why we are using map here is because when we will do the parking here, so that time we have to search for a slot for the category of vehicle that has entered, and also we have to find a slot which is available, so that we can basically allocate that particular spot to the vehicle that is incoming. So map will help us in searching or in making that search faster rather than having a list. So that is why we are using a map here. Maybe here we can use a list also, but that's fine. Now the next thing is that as part of the slot type, we will parking slot will have two method, and parking slot actors, basically what can be the method that can be added as part of the parking slot. So it will be add vehicle, so vehicle can be added and vehicle can be removed from the parking slot. There is no other thing that can happen as part of the slot individually. So that is why we have two method here, and whenever a vehicle is added to a parking slot, we will add that particular vehicle. So we will take input as vehicle, whatever vehicle is coming in, and we will initialize the value of vehicle of the slot with this vehicle, so that it stores the detail of the vehicle which is stored at a particular parking lot. And when we remove this vehicle, so at that time we'll make the vehicle as null, so that it means that there is no vehicle that is been parked as part of that slot. And we'll also make this is available as false when we add the vehicle, because it is no longer available, and next time when we search for the slot, we have to remove this particular slot from our search. And once we remove the vehicle, so it has to be made available back. So these are the method which will be available as part of the parking slot. Next is parking floor. So when we create the parking floor, that time we will assign the name and we will assign the slots. So when parking floor object is created, that time the slot has to be created, which is this map, because once the floor is created, we should know which all slots are available for which type of vehicle. And the method that is available as part of the parking floor will be, you get the relevant slot for your vehicle and park there, and the next is pick up the correct slot. So these two method will be present as part of the this particular parking floor. Basically it will be this method only, get relevant slot for a floor. So in a parking lot, when you come for parking, you will check the parking floor, on which parking floor which slot is available, and once that is available, you will return it back to the parking lot class, saying that I have got this relevant spot, so you park your vehicle in this particular spot. And the other method which I was showing will be an internal method, pick the correct slot. So we'll come to these two. And the method which is available as part of the actual parking lot will be your get instance. So there should be only one instance. This should be a singleton. So this will be only one instance of the parking lot object that we create, because in our application it should be just one parking lot. We cannot create multiple parking lot, otherwise it will duplicate the floors, slots, everything. So we have a singleton here, then we have add floor. So suppose tomorrow I add a new floor to my parking lot, that time I require this method add floors, so that I can add more floor to my parking lot. I can also remove a parking floor, because maybe the top floor has been demolished, or it is not being used for parking, it has been given for some other purpose. So that is why we have a remove floor as well, which we want to remove from our parking lot. And the most important one is assign ticket. So when someone comes, some user comes for parking their vehicle, so that time based on their vehicle we have to assign a ticket to those guys, and that particular ticket will have details like what is the kind of vehicle they have, what is the time they entered, and all those things. So we have assign ticket, and finally we have scan and pay, which means that when we are exiting, so that time their ticket will be scanned, and based on the exit time and entry time a relevant charge will be added. So these are few of the method. There are few more method, but these are all internal method, like you create a ticket for the slot and get the parking lot for vehicle and park. So we'll use it somewhere here. So let's run through the code. So what will happen is that in a normal scenario, someone will come, they will ask for a ticket, and they will park their car. So how the flow will work is, we will the first call will be made to assign ticket. In assign ticket we'll get the vehicle, so based on the vehicle we will get the parking slot for that particular vehicle. So when we go to this parking slot, get parking slot, so our parking slot initially will be null, and then we will run through our floor to get the first spot which is available. So in our floor we will basically start from the ground floor and move on, and on the floor we'll get the relevant slot for parking, which is get relevant slot and park. So how we will find the relevant slot is, from our vehicle we'll get the vehicle category. So like I showed here, we had the vehicle number and it had vehicle category. Now once we get the vehicle category, we need to map that vehicle category to a parking slot. So which should be the correct parking slot? For that we will have a mapping here. So it says that if the vehicle category is a two-wheeler, you give a two-wheeler slot. If it is a hatchback, or if the vehicle is a sedan, you give the compact type. Otherwise if it is a SUV, you give the medium type. Otherwise if it's a bus, then you can make give the large size. Now if tomorrow if we have to give we have to make a change in our code, saying that if it is a hatchback and the hatchback uh, slot is full, in that particular case you can basically allocate the medium size vehicle to a hatchback also. So we can come up with a waterfall logic here to derive the slot that we want. So small piece of code change will be required in this particular in this scenario, but it will not be major. It will just be a small if else condition or a waterfall logic which says that if this is not available, then you try for that, and that kind of logic will be allocated. In this case I am not going with that, but the code is really extensible and you can use that. So once we have picked up the correct parking slot type, then based on the parking slot type from our parking lot, we will get the correct mapping. So this parking slot is nothing but the map of slot type to the parking lot. So what this will give me here is the relevant parking slots that are available. Now out of the relevant parking slot, I have to pick up the slot which is available or which is not taken. So this will be a linear search here. This will be in O of n time, and n is the number of slot that is available for that particular category. So once this is if a slot is available, so what I will do is I will park my car there. So what I will do is, if the slot is available, so I will get the value, and in that particular slot I will add my vehicle. When I call add vehicle, what will happen is that particular slot will be made as false and the vehicle will be parked there, and I will just come out of it. If I don't get anything, so I will return from here saying that the slot was null. Otherwise I will get some slot here and I will return from here. I'll just break from here, I will get the slot and I will go back to my main method. Not the main method, this method. So once I have the parking slot, so if the parking slot is not equal to null, it means that I can break from this particular loop, which means that I have got the slot where my car should be parked. Otherwise I will look into the other floor for the same other floor to check whether there is a relevant parking spot for me or not. Once the parking slot, if I got the correct parking slot and I have parked my vehicle there, So I will go back here to my assign method where I have made the call. So here the parking slot. So if the parking slot is equal to null, I have to return from here because I have not got a relevant parking slot. I can return a message saying that the slots are full and all those things. Otherwise, what I will do is I will create a ticket for that particular guy. So I will go and create the ticket for that particular slot. So for creating a ticket, I need the vehicle number, the vehicle detail and the parking slot detail. So I will go to the ticket, and in ticket I have a builder class. So ticket will have a ticket number, a start time, end time, the vehicle for which I am creating the ticket, and the parking slot. So parking slot is nothing but the slot where I have parked my vehicle. So when I create my ticket, I will give the parking slot to it, I will give the start time, the vehicle, and I will give a ticket number. I will generate a ticket number and I will return that back. So that is how I will be creating a ticket, and I will return the parking ticket to the user, which can be printed. Now at the exit gate, I have to scan and pay. So when I come to the exit gate, I need a ticket from the user. So what I will do, I'll pick up the ticket. I will get the end time as the current time, and I will get from the ticket, I will remove the vehicle first. So I will just free up the parking slot, and once I have freed up the parking slot, I will create the duration, and based on the duration I can calculate the price. So this price comes from the abstract method that was present for that particular category. So that is how I will calculate the price. Now this part of the code can be persisted in the database. I have not done it for now, but the price, the exit time, entry time, all those things should be persisted as part of the database to do some analysis in the future, or maybe for audit purpose, or in future if someone wants to have a record of whether a vehicle was parked here or not, and for all those details. Now even in the even in the first part where we have assigned the ticket, so we need to persist the ticket that we have created for again for audit purpose, or for yeah, checking history or doing some analysis on the kind of vehicle that we are getting, and the timing and all those things, at what time the peak has reached, and for all those analysis. And another important thing here is that currently this particular code, it does not support concurrency. So if you see that nowhere I have used a synchronized method, the reason being there are multiple ways in which you can handle concurrency. So it can be at the application level, but suppose if you are using this particular application and you are using multiple instance of this particular application, so in that case synchronize might not help you achieve the result. So in that particular case, you might want to do that check at the database level. So it will be better if you make the check at the database level, where you first do a double locking kind of thing, where you check whether it is available or not. If it is available, you take the lock for that particular slot, and then you update the vehicle on that particular slot, and then come back and return the ticket. So that will be a graceful way to handle concurrency. If you are using a single instance application, in that particular case you can convert part of this particular method where you are getting the parking slot, so you can make this method as a synchronized method, and so forth. So that is how you can basically handle concurrency. Now next thing is that I will run this particular application and show you how the ticket was assigned and how the price was calculated. So there will be a main method for it, and the main method will be equivalent to the UI that will be built. So you will create your parking lot, you will give it a name, you will add address to it, and you will have the multiple slots. So this will be for each slot type. Now you will have a compact slot. So for compact slot I have given the name C1, and it will be of type compact. So the parking slot also we will have the name as C1, C2, C3, like that, which will denote that it's a compact parking slot. And for large we will have parking slot like L1, L2, L3, and the slot will also be named as L1, L2 and L3. And we'll add those things to our parking floor. So parking floor will start from floor number 1, will add the parking floor, and the parking floor will be added to this, the parking floor variable, which will be the list of the parking floor, because we have to add this list of parking floor or ingest this as part of the object creation of our parking lot. So when we create the parking lot instance, that time I have to give the name, address, and the parking floors, which will be used by this get instance method, and which will be invoked as part of this constructor, which will be a private constructor. So I will just make this new and add the parking lot or create the parking lot instance. Now once I have the parking lot instance, I need to get a vehicle. We need to set the type of the vehicle, whatever the category of the vehicle is, the vehicle number. I have to capture these things as part of my UI itself, because this work will be done by the guy who is sitting at the counter, or if it is a self-service counter, then the person has to, or the user has to enter the vehicle number and their category. Based on these two category, ticket will be assigned. So we'll get a ticket, we'll print this particular ticket, we'll sleep for some time. Why we want to sleep for some time? Because this will denote the time for which you are basically waiting for, or you have parked your car. So in actual application where you are using a Spring Boot application, you will not have a sleep or anything like that. There will be multiple endpoint. One endpoint will be there to create your assign ticket, one endpoint will be there for scan and pay, but in this particular application I'm just using it together. So let us run this application and see how the price was calculated for a hatchback vehicle, and we can basically change this category anytime we want. So here the ticket number got generated. So this is the ticket number. So ticket number was the vehicle number, and a timestamp was updated to it, and finally the price was calculated. So price was 0.75, which is the vehicle which we have used is a hatchback vehicle, and for hatchback vehicle it will be under compact, and the price will be 0.75 because we were there for like 10 seconds. So this is how this application was created, and that is it for this particular video. Do let me know if you want to make any changes in the approach that I have taken. Do let me know in the comment section what is it that you can do better, or what is it that you can do to make this program better. You can get the link of this code in my GitHub, and the GitHub link is there in the description, so you can check that out. And that is it for this video. See you in the next one. Take care. Bye.